Hey, what's up? Leetcode 686, binary gap. Given a positive integer, find the longest distance between any two adjacent ones to the binary representation of n. If there are no two adjacent ones, return 0. Alright, okay. 10 to the 9th. Alright, trim 0. Trim B. Trim 0 for I in reverse. And length X. Yeah. If 0 times I in X turn I. Yeah. The first adjacent pair of ones at the distance of 2. Okay, what? str object has no attribute trim. Do you mean strip? Yes, actually I did. 8. 1. Oh, right. What? Alright. Now let's go register for the contest. Okay, weekly contest. Register. Alright. Okay, I only lost about 7 minutes. Okay, question 1. Find the score difference in a game. You're given an integer array nums where nums1 represents the points scored in the ith game. There are exactly 2 players initially. The first player is active and the second player is inactive. The following rules apply sequentially for each game I. If nums I is odd, active... Oh my god. I have groceries I need to put away. No, let's figure this out and then I'll put them away. Okay. If nums I is odd, the active and inactive players swap roles. Since the points are odd, the second player becomes active and gains... Second player gains... Initially, the player is active. Okay. Player 1 equals true, I guess. For I in nums. Okay, if it is odd, if I mod 2 P1 let's do which player, right? Okay. In every 6th game, the active and inactive players swap roles. Which way does enumerate go? Enumerate index like this. So if j plus 1 mod 6 equals 0, okay, the active player plays the ith game and gains nulline points. Return the score difference defined by the first player's total minus the second player's total. Alright, so scores equals 0. Scores which player plus equals I. Return 0 minus scores 1. Alright, let's see here. What? Oh, right, I always forget. Okay, output 0, output 0. Output 4, output 4. Output -1, output -1. Submit. Alright, and it was accepted. Okay, I'm going to put away my groceries and then I'll be right back. Hey, I'm back. Sorry, I cut myself on some aluminum. The tab said pull to open, and I pulled to open, and aluminum tore, and so did my finger. Okay. Question 2. Check digitorial permutation. You're given an integer n. A number is called digitorial if the sum of the factorials of its digits are equal to the number itself. Determine whether any permutation of n, including the original order, forms a digitorial number. Return true if such a permutation exists. Otherwise, return false. So it's basically like integer partitioning, right? But there's at most 9 digits, so there's at most 1,024 different combinations. I wonder if I should just brute force it. All right. Any permutation of n. All right. 1, 0 is not equal to 10. Oh, interesting. I misunderstood. Okay, it can't start with a 0. Okay, so I have to calculate the number first. Yeah, so let's just say f equals 1, and then for I in range 1 to 10, f dot append f of -1 times I, right? That should be our factorials. Excuse me, print f. So 1, 1, 2, 6. Yeah, that looks right. Okay. Okay, so sum of factorial digits equals sum of f of int of I for I in strn, and let's make sure that that is correct. Sum of factorial digits, 145 seems to be working. 145 exactly equals, so if some factorial digits equals n, then we're good to go. let's do n as a string, str of n, and then we put this here. Sorry, bleeding everywhere. Okay, so in that case, okay, it would need to be the same length, right? If length of, well, let's do ss equals str sfd. If length of ss does not equal length of an s, then return false. Then if sorted ss equals sorted ns, then return true. Actually, we can just, so let's see here. Closing parentheses does not match open. Invalid syntax. Sorted SS. Oh. Yeah. Okay. True and false, right? So let's see if that works. Accepted. That means that it passed, right? Yes. Yes, it did. Okay. Next question. Maximum bitwise XOR after rearrangement. You're given two binary strings S and T, each of length n, so they're the same length. You may rearrange the characters of T in any order, but S must remain unchanged. Return a binary string of length n representing the maximum integer value obtained by taking the bitwise XOR of S rearranged with T. So basically, we're saying we want to flip bits, and then we might not want to flip bits, and so we choose the highest and lowest bits respectively, and we return it as a binary string. Okay, so you may rearrange the characters of T in any order. So we're going to say C equals counter of T. Right? Okay, and then we're going to say output equals list of S. Okay. And we really don't need to know. We just need to know the ones. C is the ones. So what we're going to do is we're going to say for I in range length O, yeah, and then if C equals 0, then break, and we're done. Otherwise, if O of I equals 0, then in that case, O of I equals 1 and C minus equals 1, right? Okay, so now let's make sure here. Assert C is greater than 0. Assert C equals 0 or not in O. Because if there was still a 0, then we should have used it. I think that assertion is completely superfluous, but let's just make sure here. No assertion, no assertion, no assertion. 2. Damn it. All right. I mean, it's going to fail otherwise. All right. Now, if C is non-zero, then we're going to be forced to... let's leave this. If I... for I in reverse range. Now, unfortunately, we are being forced in this case. If C equals 0, then break. Assert O of I equals 1, and O of I equals now 0, and C minus equals 1. Okay, just return dot join of O, I guess. Let's see if that's right. So output is 1, 1, 0. 1, 1, 1, 0. Return a binary string of length n representing the maximum integer value by taking the bitwise XOR of S with the rearranged T. It's right. You can't flip it twice. You cannot flip it twice. Interesting. R count 0, count 1. O. I mean, is there any reason ten to the 5th? So in this case, 1, 0, 1, 1. Yeah, we can't flip it again. What an interesting question. There isn't really a choice, though. Count 0, count 1, O, I, right? Yeah, if we could flip a higher bit, we would always want to do so. But we might choose to to flip a bit, here, let's go back to what we had. Okay, we have to figure out what the logical reason was that we didn't flip that. It's because we had too many ones. That's what the problem was. If T has more ones than S has zeros, then we have to be smarter about it. So because you can't flip it twice. So the output I don't know what the optimal is. We can't do every single combination. It's 2 times 10 to the 5th. Okay. I can reason through this. We want to flip the bit unless flipping the bit forces us Okay. So count T0, count S0, count S1, and then O, and then I, right? So OSTR equals list of S, right? Yeah, and then CS of 0, CS of 1 equals, well, just say C equals counter of OSTR. And then this will be C of 0, and this will be C of 1. Okay, and then exactly the same thing. C equals counter of T, and then this will be CT of 0 and CT of 1. Like that. Now, I'm hoping that we can make this decision as we're going. Right? Okay. If length of O is less than or equal to I, then we are done. Do we really need recursion? I don't feel like we need recursion. So for I in range length O. Okay. if OSTR of I equals 0, first off, if count of t of 1 equals 0, then there's nothing more to do. If count t of 0 equals 0, then we have no choice. We have to flip the bit, right? So it doesn't matter. It doesn't matter at that point. Let's see. ORD of 0. Cool. All right, then OSTR of I equals CHR of 1 ORD STR of I. We're flipping it, and we don't have a choice. Otherwise, we do have a choice. Okay. Now, if it is a 0, and we have established that there's at least one t, then we do want to flip it unless flipping it is a bad idea. Because it would force us to flip something down lower, right? But whatever it is, it's going to be lower. Yeah. There is no case where we don't want to flip this one. So this is going to be CT of 1 minus equals 1 and OSTR equals 1. Yes. Now in this case, it is 1. And this is where we have to make a decision. Do we need to branch? If we need to branch, then we need the recursion. I'm not sure that we need to branch, though. I think that we can logic this out. So, wait. Okay, in this case, CS of 0 minus equals 1, and CS of 1 plus equals 1. No, because it's remaining. It's remaining. We don't need to increase. Okay. So, if CS of 0 is greater than or equal to CT1, then we do nothing. There are enough spaces to leave it. Otherwise, we want to push the ones as far back as possible, right? We would like to push this back unless we don't have a choice. Yes. And we've already established CT of 0 does not equal 0. Is this it? Is this the entirety of what we need to do? If CS of 0 is greater than or equal to CT of 1. Okay. So what is the opposite? This is CS of 0 is less than CT of 1. In which case we need to find out how far off we can push it. How far back can we push it? Well, it's just however many zeros there are. But we already know that it's non-zero. I think this is it. No, it's not it. We've already established that CT of 0 is non-zero. It is non-zero, which means we can push it. Then what's the difference between the two? There's no choice. Maybe this is the logic, not this. There are enough spaces to leave it. All right. Am I overthinking this? Counter is not defined. Okay. Output is 1, 0, 1. Print CS0, CS1, CT0, CT1, I. Okay. Why is this only 2? Because we used it. We used the 1, and we shouldn't have. So we encountered the 0. and we flipped it. We encountered the 0. Encountered 1. Encountered 0. 1, 0, 1. 1, 0, 1. And when it encountered the 0, it didn't flip it. OSTR of I equals 1 at position 1. We were here. We were here and we didn't flip it? Forget this part. This should have flipped this. Why didn't it? Oh my God. All right. Now it's 1, 1, 1. That is not correct either. Because CT of 1 CS and CT are both 1, right? It's not decrementing properly. That's it. CT of 0 minus equals 1, right? And CS of 1 minus equals 1. So we consume the 0, we consume the 1. Okay. Okay, so as long as there are more zeros than there are ones, then we do this. These seem identical. Okay, 1, 0, 1. 1. God damn it. We encountered a 1. We decremented the 0, right? Which is correct. Encountered a 1, we decremented the 0, and then it was at 0, forcing us to flip the remaining bits. But there was only 1. I don't think we can break. If CT of 1 equals 0, then nothing else can change. That is correct. If CT of 0 equals 0, then everything has to change. We don't have a choice. Can I split on this? It seems like once we've committed to swapping, then we have to keep swapping. Okay, I think that we had the right idea at first. Okay. So ones equals... Okay. O equals str of I, right? Str of s. So ones is I for I in range length O if O of I equals 1. And then zeros, and these are sorted, right? Maybe we should do the ones that we're forced to do first. That might be the secret. Okay. Count of flips equals str of t dot count. It's already a string. Yeah. T dot count 1. Like that. Okay, so we want to flip. If we're forced to flip things, we want to flip the lowest bits, right? I swear this is not as complicated as I'm making it. Okay, we have 101 and we have 2 flips, right? And the correct output is 110. Yeah. Okay. If count of flips is greater than length of zeros, well, let's do while count of flips is greater than length of zeros, then we will choose the smallest one and flip it back. So I equals ones dot pop and O, well, let's do assert O of I equals 1 and it equals that no more. O of I now equals 0 because we've been forced to flip it, and the number of flips decrements like that. Okay. Now, for I in range length O, if O of I equals 0, first off, if that highlighting is freaking me out. If it's less than or equal to 0, then break. If O of I equals 0, then O of I, I almost did it again, equals 1, and count of flips minus equals 1, and then we're going to do assert count of flips equals 0, and return dot join O. Okay, 110. 0. Oh, for hell's sake. What's the next problem? Count sequences to k. You're given an integer array nums and an integer k. Start with an initial value val equals 1 and process nums from left to right. At each indexed I, you must choose exactly one of the following actions. Multiply val by nums I, divide val by nums I, or leave val unchanged. After processing all elements, val is considered to be equal to k only if its final rational value exactly equals k. Okay. So we can multiply, divide, or leave it unchanged. Nums.length. Is it just me, or does this seem like a brute force problem here? Yeah. The following 3 distinct sequences of choices result in val equals k. Multiply, divide. Division is rational exact, not integer division. That makes sense. So we have every possible value at every possible point in time. There's only 6 numbers. This is kind of weird. Okay, multiply, divide, or unchanged. Yeah, we would divide to get smaller. Okay. I think we can do all of the multiplies first. Doesn't that make sense? And then only if we had an extra factor would we divide. No, not necessarily. I.length 19. I wonder if we can just brute force it. I mean, okay. Vals equals, well, like that. I don't know. Maybe we can brute force it. So we're going to say for I in nums is there ever a reason we would want to divide first? No, I don't think so. I think we could always divide after. Let's make this 1, 1. Okay. For yeah, now our three choices are going to be, we have to okay, import math, greatest common divisor, from math import least common multiple, no, greatest common divisor, that's what we want. And then, yeah. But if you have two things that are relatively prime, then it's going to be, all right. From math import greatest common divisor. So choices are leave it alone, which doesn't require any interaction, or multiply or divide, right? So n2 d2 equals this times 2. No, times I. And then n3 d3 now we have to reduce them. Okay, so G equals greatest common n2 d2, and then n2 G d2 equals G, and then 3. Okay, these are all of our choices. So we just have to add them back. Vals dot add n2 d2 and n3 d3. Yeah. Now, if it's 1, well, no, let's see if this works. Let's see if this works. So if k comma 1 in vowels, then return the following distinct sequences. Output 2. Return the count of distinct sequences. Okay. Okay, that's fine. C equals counter. And then C of 1 comma 1 equals 1, right? Okay, so 3 choices. Leave it alone. That should come last. Okay, for n comma d in vowels. It's almost like we need to save these and then update them at the end. Yeah, actually, I think that we are. Yeah, this is not going to work. Because we're going to be introducing values while we're still using them. Okay, so C last equals C dot copy, shallow copy, right? And then N comma D is going to be the key, and then CNT is going to be the count for C last dot items. Okay, now each of these will end at a distinct place, and that is going to increment. We need to eliminate this integer division. Right? Yeah, this greatest common denominator bullshit is just going to get out of hand in a hurry. 2 times 3 times 5. Those are our choices. Up to 19 times. Python. 2 times 3 times 5 is 30. And 30. All right. So what if we started with that number? Big ass number. Okay, it's not that crazy though. This would allow us to use integer division, right? Yeah. So we're going to say multiplier equals that. And C of multiplier equals 1. Okay, this will work. So we will say for I comma CNT in for J in nums. Yeah, so every way to arrive at a specific value for I comma CNT in list of C dot items. That'll force it to make a copy. And then we have these choices, and then our destination is going to be K times M. Basically. Now, we have 3 choices. Keep the same, multiply, divide, right? Keep the same is simple enough. Okay, C. Is there a clear? That would be best. Yes. So C of M plus equals CNT, right? It's the number of ways that we could get there. And then C of M times J plus equals CNT, and then C of M divided by J plus equals CNT. And it wants to know the number of paths, so it's simply return C of D, which is the destination. All right, output 0. That does not sound right. All right, print I comma CNT. Print C. Empty counter. That's interesting. All right, 111333. 999 0. Print J. So 1162, 1162, and then what was our D? D. So our D, where the hell is D? Our D was this divided by this, right? Times 6. So it should have been times 2 times 3. Yes. That is correct. So this is this times 2. Then this should have appeared again. And then this times 3 should have been our yeah, but we repopulated at the end. It's repopulated every time. Something very strange is going on here. Yeah, this number should be increasing, so J is 2, so that's this one right here, right? Yes, and then this should be times 3. Do I have like an errant break in here or something? I.CNT. Wait, not M. Not M. Oh, God. Okay, 2, 2, 3. Okay. Get rid of the extra prints. Submit. 998, 998, and it passed. All right, sweet. Wait, what? Oh. I guess I got confused. Okay, you know, when in doubt, you use recursion, I guess. I don't think we can do this at this point, but let's just see what we can do. CNT equals T dot count of what? Of 1. Alright, def R LRU cache none. Def R position remaining count. Okay. If I equals length of O, then return. Right? If C or C equal, there's nothing more to do. If there is a 1, yes. Now, if O of I equals 0, then is there any reason that we wouldn't want to flip it? No. No, there isn't. How am I going to return this? Yes. If C equals 0, then return O of I plus R of I plus 1, commas. Right? Okay, now, this is the moment of truth. This is absolutely going to time out, but the contest is over, man. What do you do? Okay, so choice 1 equals 0. R of I plus 1. Choice 2 equals 1. Yeah, now we have to use it, though. If the number remaining is equal to C, then we have to use it, right? So remaining equals length of O minus I. If remaining is greater than or equal to C, then we don't have a choice. we have to flip it. So we say CHR of ORD of O of I, right? That's, we don't have a choice. This is, we do have a choice, and we want to flip. And this is, we don't know if we want to flip or not. So we've already determined that a choice exists here because of this, right? So this is it. This is our choice. If choice 1 is greater than choice 2, then return choice 1. That's stupid. Return max of choice 1, choice 2. And they're the same length, so that's fine. So return R of 0, comma, CNT. Invalid sequence. Okay, output 0, 1, 1. Zero, 1, 1. Print I, comma, C. Print remaining, comma, C. Okay, 0, 2. T dot count of 1, right? So 3, 2. All right, so 1, 1, 0. 1, 1, 0, 1. And okay, so print is gone, run. I think it's going to time out. Memory limit exceeded. Well, same basic concept, I guess. Okay, zeros equals 0 equals I for I in S, right? It's an integer. And we want the remaining from the right. So remaining reverse accumulate equals list of accumulate of reverse of zeros. Reversed again, right? The list, print, show me. So 2, 1. All right. Okay, so if we're at a 1, we want to know how many 1s there are left, right? So, if C is less than the remaining 1s of the position, well, I tried. Do I get to see the results? Yeah, I think that's pretty good. I feel like I should have known how to do this, but whatever. Well, I mean, this solution worked. I just, just don't have all the memory in the universe. Thought it was going to time out, but out of memory is just as bad. If C is less than R0, oh well. So sad when that happens. Okay, let's see where we stand. Wait, contest, go to the contest. Is that all ready for that next week? No, that's us. Now it always moves up when they get rid of the cheaters. So I am currently ranked 4,574 out of 43,022. Okay. So what percentile is that? And it'll get better too. So 43022 minus 4574 times 100 divided by 4574. What the hell? Let's try that again. 43022 minus 4574 times 100 divided by 43022. 89th percentile. So when they get rid of the cheaters, I should be in the 90s. Oh well. Oh, guess I'm done. See ya.